Hello everyone, this is Vaibhav and you are watching the second lecture on the topic University Functions. I hope you have watched the first lecture on the topic University Functions. In case you have not watched the first lesson, then please go through the video section of this channel and watch it. Then come to this video lecture. So without wasting any time, let's get started. So firstly, if you remember that at the end of the first lecture, I gave you some homework questions. So let's just find out the answers of those homework questions firstly. So the first question was, it was given that the set A is of the real numbers and R is defined like a set containing the pair A, B such that A and B are in A. A and B are in A means A and B are real numbers and satisfying this condition. I have told you this is the main condition on how A and B are defined. That means what elements will this set contain. So here we have this condition that A minus B must be less than 5. So all those pairs would be in this set. Then it is asking you whether R is a function, or second thing, whether R is a relation but not a function. Okay. So basically you are asking R is a relation or function or not. So let's reveal the answer, which is nothing but B, that it is a relation but not a function. And we will see how it is not a function. So let's go to its solution. Now, clearly it is a relation. I told you just two things you need to verify. A set with a set containing ordered pairs. And these two it is having. By this ordered pair and the set. So clearly means it is a relation, no doubt. Now, in order to verify or check whether it is a function or not, we will be looking at its graph, because many times it is very easy to find out whether some set is a function or not. And basically in these types of questions, the graph makes the question very easy, because it is not easy if you are not perfect to find a pair that do not satisfy this function condition, that any two different order pairs can have the same first component. If you can find them, that's good, but in case you don't, then this is the good criteria to look the solution with the help of graph. So let's draw this graph and find out what can be the elements of this relation. So let me draw the axis first and name the x-axis as A and the y-axis as B, because that is given to me. Okay. So now let me just draw this graph. Okay. I am drawing the graph of A minus B equals to 5, because I need to find the graph of A minus B less than 5. So that would be either the region above this line or this region, the below line. So I'm drawing the graph of A minus B equals to 5. Okay, so this is the line and it meets this x-axis at the point 5 comma 0 and y-axis at 0 comma minus 5. So it is a 2 point of intersection. Okay, now in order to see which region this represent A minus B less than 5, whether above or below this A minus B equal to 5, just took any point above this line and any point below this line and satisfy this inequality given to you. Okay, so now clearly this point 0 0 origin is a point lying above this line, so I can take. So if I just put, then what I'll get, A is 0, B is 0, so that means A minus B is 0 and 0 we know that is strictly less than 5. So that means this inequality is satisfied. So the region would be above this. Now in order to see why can't it be the below region, let me just pick one point, any point among this whole region, any point, in order to look whether it satisfies this inequality or not. Okay, so if I can take this point is basically 5 comma minus 5. It is lying below this line, A minus B equal to 5. Now let me just put A as 5 and B as minus 5. So what it would be? Minus minus would be plus, and a plus b would be tan. Now tan is not less than 5, right? Tan is not less than 5. It is not satisfied. Similarly, you can take any point to see whether this is region or not. So up till now we know that this is the region, the line and the region above this line a minus b equals to 5, which we are looking for, which is basically this region a minus b less than 5, right? So let me just shade this region. It can be like this. So this R contain all the ordered pairs in this region. This is basically infinite number of points. It's not limited to this only. It goes up to infinity over here and to here as well. Okay. Now it is very easy to find whether it is a function or not. How? You can just put any 2 points whose x coordinate, that means this point lying on this a line, and y coordinates are different. So let me just put 2 points 0 comma 2, which is lying above here, and 0 comma 2, right? Firstly, these 2 points are in this R because these are real numbers, no doubt. Second thing, it satisfies this inequality. How? 0 minus 2 is minus 2, and 0 minus 3 is minus 3, which both are less than 5. That means both are in this relation R. Now, but these 2 points fails the condition for R to be a function. How? These are two different ordered pairs and they have the same first component, which we do not require for a function. So that means R is not a function, just a relation, and that means B option is correct. I pick up these 2 points 0, 2 and 0, 3. You can put any 2 points just in order to fill this property. In case you find the points very easily without drawing the graph, you can do so as well. I can put any 2 points. Suppose I have this line at minus 4. Now I can put any 2 points. Suppose I put minus 4 comma 1 and minus 4 comma 5. Now both are different, but they have the same coordinate, minus. Okay. So I hope so this first question is clear to you. So let's now move to the second question, which is this. In the second question, it was given that T is a set containing the pairs A comma B such that B is equal to A plus 1. Okay. So here in the earlier question, A and B were given as real numbers, but here also it's not given what can be A and B, but it is always assumed, if nothing given to you, just it is always assumed that they are real numbers. Okay, this is the condition. And also given the condition which A and B satisfies to be the elements of this T set. Now it is saying that T is not a function but a relation. That means it is not a function, just a relation, and you need to say whether it is true or false. So let's see the answer. It is false basically. It is a false statement that it is not a function but a relation. That means it is a function. And function implies relation only. Okay, so let's see the solution now. Clearly, T is a relation, no doubt. A set with the ordered pair. So we need not to argue with that thing. Okay. Now again, in order to see whether it is a function or not, we will be just drawing its graph in order to tell you. Like as we did in the previous questions, like as we did for y is equal to sin x and y is equal to mx. So in that cases, similarly we'll do over here. Okay. So let me draw the x's first and name them as a and b, which is given to me. Okay. Now I have to draw this line y is equal to a plus 1. So on plotting the points, I'll get this line. By b is equal to a plus 1. Now, it intersects the x coordinate x-axis and the y-axis, basically A and B line at these 2 points -1, 0 and 0, 1. Okay. Now it is not an inequality over here. That means it is not a relation like less than or greater than. It is just equality sign. So the region is just this line only. That means the coordinates, the pair to be in this set would be the points on this line. And these are also infinite. Because we can have infinite number of pairs. No doubt. Now it is a function because anywhere if you take any point, then you would be having just a single point. That means if you take any point on this line, right? So for one x coordinate, you will be having only one image. If you take here, for one x coordinate, only one image, not two. Means you do not have this case over here. That means this point has two images. Okay, or you can say the two distinct ordered pairs with the same first component. So it cannot be the case over here. So that means it is a function, and in order to learn a result, you just simply learn this, that straight line is always a function. So whenever you are given the relation of a straight line, then you can directly say that it is a function, no doubt. Like as we did in the earlier case, y is equal to mx. So there we also draw the graph and find out that that was a function, right? And you can also just do like this. So in general, for y is equal to mx plus c, it is the result is true that it is a function if the relation is like this. Now I am saying for the equality only. I am not saying if it is less than or greater than, then the result is true. No. I am just saying for the equality when it is a line. Okay. So I hope so you are clear with this second question as well. So let's now move to the next one. The third question was given to you as this set P containing the pair x, y and how x and y are related. Now here we do not have a mathematical term like in the earlier ones we have x square equal to y or x is equal to y plus 1, something like that. But here we have a relation, a serious relation, which is that x is wife of y. Means this is the wife and his husband is x. That means we have a pair of a couple, a husband-wife, where the wife comes first, then the husband. Okay. And you are given the options that neither a relation nor a function or just a function. That means not a relation. Okay. Now, if I just ask you right now without showing the option, then one option you can easily discard, which is this one. Can I ask how? Think before you answer. This is an easy question. You can just, it is saying just a function. That means this is a function, and in bracket it is written not a relation. That means this is just a function but not a relation. Can this be true? Definitely not. Because in the function definition we just say that it must be a relation first in order to have a function. So this can't be true. If it is a function, then it is always a relation. So this option is automatically discarded. So we are just left to check this thing whether it is neither a relation nor a function. So well, the answer is that none of these options are correct. B is not correct, we just told you, and A is also not correct. Now how it is? Let's see. Now clearly P is a relation. Okay, and as I told you, these elements ordered pairs are just nothing but couples in of this one. Wife comma husband. So we have a wife and there is husband as the ordered pairs of this set or the elements of this set. Right? It is a relation, no doubt, a set with the ordered pairs. Clear? Okay. So now we can't draw the graph. right? But we can just check whether it is a function or not. And I hope you also know that it is a function. So before answering to that point, let me just state you something. Suppose I have a wife, okay, within this red circle, and I have two husbands. Husband number one, which is this, and husband number two. These are two different. You can also see their colors are different in order to denote that these are two different. Now, can I have this thing that this wife has husband one as his husband and husband two as also his husband? Can this be possible? That means this is mapped to these two. Definitely not. This is not the case. This cannot be possible. That means this wife can have two husbands. Not now. This cannot be the case. That means for a particular husband, we can have a particular wife only. Or for a particular wife, we can have a particular husband only. We can't have that two wives can have one husband. Or two husbands can have one wife. This is not the case. We are talking in general. Just remember that. So this can't be the case over here. And which is just sufficient to say that P is a function. Because we do not want the same image. I mean, we do not want the same first component, which is wife over here. Right? Okay, so now I have a question. If I just replace this question by the replace the pair in the question by like this, that the first I place the husband and then I place the wife, and the set is like P is equal to H comma W, where H is husband of wife W. Then what can you say about these two options? Or this also, there's a third option if I just put. What can you say? Whether A is correct, B is correct, or C is correct, if this is the case. That means first I am placing husband, then I am placing wife. Please pause the video right now, answer yourself, and then replay the video. Well, let's see which of these three options will be correct then. So B option is itself neglected because it is saying it is a function but not a relation, which can't be possible. So B option will not be true. Now the choice is whether A is true or C is true. So it is saying neither a relation. Wrong. It is a relation consisting of the ordered pair, that means A is wrong. Now the question, whether C is true, that means none of these two options are correct. Okay, so it is automatically true because these options are not correct, right? So it is automatically true. So now just have to verify the two things, whether this pair is a relation or a function or none. Okay, so none option is not there because we have just neglected the first one, right? It is a relation clearly. Now for the function thing also, same thing we can see. If I just put wife 1 and wife 2 and husband, then husband can't have two wives, right? I'm talking in general. Husband can't have two wives. Again the same thing we can see, and again it is a function. This thing will not be happening. This thing will not be happening over here also. So that means if I just place husband first and wife second, then doesn't matter. It would definitely be a function. Thus, the set P is a function as well. Okay, let's now move to the next question, which was this. So it was giving you the set M, which is like this, and B is equal to A. This is the relation, how it looks like, how these are two related, and is telling you it is a function. You have to state whether it is true or false. So without wasting any time, let me reveal the answer, which is false. Of course, it is false. Okay, let me just tell you. how it is false. It's clear from the definition how it is being defined basically. It is not a relation as well because we do not have the ordered pairs over here. We have the set, no doubt, but we do not have the ordered pairs. Ordered pairs are written in the round brackets in the form a comma b type as I written earlier, not by these curly brackets. These curly brackets denote the set. These denotes the set, not the ordered pairs. Just note down the difference. So it has a set a comma b. That means this set contains the set a comma b, and the relation is like that b is equal to a. That means when a is equal to b, because in set we do not copy the elements. We do not write a comma a. So either it would be only a singleton a or it would be only when we have a when we have a just one element in the set, we write it as singleton. We call it the singleton. So that means this M would be having the elements like this. It would be a set containing this set, this element A. Okay. So either it would be this or it would be like this. A set containing the set B containing the element. Set containing the set which containing this set. So either this would be the element or this would be the element. Anything can be there because B is equal to A. If B is not equal to A, if the thing was like B is not equal to A, okay, then we would be having only this A comma B. We would not be writing like this. We are writing it like singleton A or singleton B because we are given that B is equal to A. That means either we write A or B, doesn't matter. Okay. So if the thing is B is not equal to A, then basically it is just A comma B, nothing else. Because we don't know how A and B are related. Okay, so it is not a relation because it is just a set, not the ordered pair, which we want for a relation. So it is a function, it can't be a function if it is not a relation. So that's these two. These two means this M is false. Okay, this statement is false. So let's now move to the next one. And the final one question. This one is the important one. And it is asking you that the set Z denoting this empty set, whether it is a relation or not, asking it true and false. I hope most of you did a mistake. I hope so. In case you did not, then you understand the concept of relation and function very well. So let's check your answer. It is true. Okay. Empty set is a relation. Now, in case you got the correct answer, then all the best. You understand the concept of relations and functions very well. In case you are surprised by the answer, then look at this explanation. I'll explain you how it is a relation. Okay, just look at this explanation. Okay, so empty set is basically a relation. Okay, how? Let me just consider an example. Suppose I have a set A containing 4 elements 2, 3, 5, and 7. Okay, and I define the relation. For now, I'm not telling it is a relation. Let me just take it as a set. As a set containing the pair A comma B such that A square is equal to B and A is in A and B is in A. That means A and B both belongs to the set A. That means A and B can take the values from this set only. Okay, as I earlier told you that in some questions I write A is in R. That means A and B are real numbers. So they can take any value. Similarly, A and B are here, these 4 ordered pairs. So they can take the value from this, not ordered pairs, from these elements only. And they are related like A square is equal to B. Okay. So let me first write the elements in the set, which can be, so it is basically an empty set. That means there is no element in the set. How? Okay, suppose I take A as 2. Then this must be the condition followed by A. That means its square is B. So A square would be 2. 2 square would be 4. Now 4 is not in the set, so B can't be 4, because if B is 4, then it must belong to the set. That means B can't be, that means A can't be 2, and similarly B can't be 2. Okay, I just can't take them both. Similarly, if I take A 3, 20 square is 9, which is also not in the set, that means A can't be 3, and also B can't be 3. Similarly for 5, H square is 25, which is also not in A, because elements A and B are in this set only. So A is not equal to 5 and B is also not equal to. And similarly the last element 7 square, which is 49, which is also not in A. So A can't be 7 and B can't be 7. So that means A and B can't take any of the values of this set. So that means there is no element in the set, and we denote it like this, 5. So R is 5, that means it is empty set. This is true. So R is an empty set, and this type of relation which I define is called an empty relation. It is by definition we call this as an empty relation. Okay, so I hope you get answers to all your homework questions. In case you further have any doubt, please mention in the comment section, mentioning the question with which you have it. So now after this, with these homework questions, let's start today's session with the topic inverse key function or inverse circular function. Okay, so one by one we will go through the topic and deal it more clearly, deeply, as far as we can go. So firstly, let me just tell you how to define these inverse trigonometric functions and how it looks like. How can you just write it? Okay, suppose if I can write sine of alpha equals to x. Okay, suppose I have this. I write sine of some alpha equals to x. Then this. If I have to write alpha, then I'll be writing alpha as this. Sine minus 1x, which can be read as sine inverse x. This minus 1 read as inverse. Okay, so this is sine inverse x. In this way I define. Now what is this inverse x? What is this term? You have not read this term. You know the sine term. Okay, but you did not know what is this. So basically, sine inverse is a symbol. It's like a symbol that we have in mathematics, like we have the symbol pi, alpha, beta, gamma. So these are all symbols, right? Similarly, we have the symbol sine inverse. It is a symbol. Now what it denotes? It denotes an angle. What angle? This alpha. This is the angle which this denotes, right? This is equal to this, na? Sine inverse x equal to alpha, which is nothing but the angle or a number, I can say. The value of whose sine is x. Value of whose sine is x means this thing. That means the sine of this angle or the number. The sine of this thing is the x. Right? Are you getting that? So whenever I would be having sine of some alpha equals to x, then I can write alpha as sine inverse x. In this way, we can define this inverse sine function. Inverse sine function. Okay? Clear? Now, as I define sine inverse function, I can define other trigonometric functions as well. Like this. I write sine of alpha equals to x. I can write cos of alpha equals to also x. Then alpha would be cos inverse x. Read as cosine inverse x. If I write tan of alpha equals to x, then alpha would be tan inverse x. If cot alpha equals to x, then alpha would be cot inverse x. If sec alpha equals to x, then alpha would be sec inverse x. And if cosec alpha is x, then alpha would be nothing but cosec inverse x. So whenever I would be having something like this, cos of something or sine of something or any trigonometric function of some alpha equals to x, then I can write that alpha as the inverse of that trigonometry. and can define the inverse trigonometric. Okay. So now you are clear with how inverse trigonometric functions are defined and how they come, where they are coming from, right? From here they are coming from, right? By this notation, this notation. So now let's have a more clear idea by doing some example. Suppose I have to find the value of sine inverse half. Okay. Now a tricky question. In case you don't know how to do this, let me help you. We will do this question similarly in the same way as we just define sine inverse or other trigonometric functions. We know that sine of pi by 6 equals to half. That means sine 30 is half, right? You know this. So earlier I write what? Sine of alpha equals to x. Then alpha would be sine inverse x. So similarly here, alpha is pi by 6. So pi by 6 would be sine inverse of half. I can do this. And what I need to find? Sine inverse alpha. So the sine inverse of half is pi by 6. Very easy. Just what you need to do. The number whose sine inverse you need to find. You need to find that at which angle of this trigonometric function we get this value. Like I know that at pi by 6, that means at 30 degree, the value of sine is half. Okay, so at 30 degree sine is half. So I can write by this that pi by 6 will be sine inverse of half. And this is basically the answer. And you clearly have to know the trigonometric tables in order to do these types of questions. Let's do one more question to be more clear. And this time, please do this question by yourself and then look at the answer. Suppose I am asked that find the value of tan inverse of 1. Okay. So I am giving you a time. Please do this question. Pause the video. Do this question and then replay the video in order to get the idea that you are clear with this thing. So I hope you are clear with this question. Let me tell you how to do it. In this case, you don't know how to do this. First thing, you know, tan has the value 1 at which angle? At pi by 4. Pi by 4 means 45 degrees. So tan at 45 degrees is 1. That is tan at pi by 4 is 1. You know this? Now you are done. So pi by 4 can be written like tan inverse 1, which is you have to find. That means tan inverse 1 would be pi by 4. Easy. Just whenever you have to find this inverse function, you need to find at which angle of this trigonometric function you have got this value. And that is your answer. Just need to first write this thing that at the trigonometric function at this angle I am getting this value, and then do as we define the inverse trigonometric functions. These are very easy and very simple functions. So I hope you are clear with these examples and how to define them. So let's now reveal you something. The functions that I just taught you. Sine inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x, and cosec inverse x. These all functions are just the inverse trigonometric functions or inverse circular functions. Okay. These functions which you are using to do the calculations, which are the symbols, these are just the inverse trigonometric functions. Okay. Now you might be questioning yourself, why are these called circular functions, inverse circular functions? Well, I'll reveal that mystery a little bit later. Okay, so before that, let me just further elaborate this topic in order to have a clear idea of what are these functions, to have a more general notation. and to be clear with the details. Okay. Then we will reveal this topic. Why are these called inverse circular functions? But in case you have a attitude that you wanted to know it right now, then please Google it. Or if you want to let me tell you, then please wait until I reach this topic. Okay. Now, an important notation I'm going to tell you that there is one more notation possible to write these inverse trigonometric functions. That means this is not the only way to write any inverse trigonometric function, like you write the trigonometric function, then write -1 and then write x. So there is one more thing that you can write like this is the thing. Suppose I have to write sine inverse x, then I can also write sine inverse x as this. Just using this word arc before the trigonometric function. So if I have to write sine inverse x, I will write arc sine of x. Similarly for any other inverse trigonometric function. Suppose I have to write sec inverse x. I will write arc sec x. For tan inverse x, arc tan x. Just remember this word I have used, arc, before the trigonometric function in order to write the sine inverse. So many times the question could be like this. They would not be directly asking you that find the value of sine inverse of suppose half. They would not be directly asking you to find the value of sine inverse half. They will say find the value of arc sine half. Now, if you know that arc sine half is nothing but sine inverse half, then you can do it that question easily. Otherwise, you just leave that question because you don't know that arc sine x is nothing but sine inverse. So remember this thing. This is an important point. Okay. This is an important point that you must know. Okay. Now, an important caution. Sine inverse x does not mean sine x to the whole inverse. Many of you up till now take sine inverse x as this thing. Now, this is not true. Remember that. If someone tell you that you can write sine inverse x as sine x to the whole inverse, this is not the case. Because sine x to the whole inverse is nothing but 1 upon sine x. And which is equals to this cosec x, not cosec inverse, this cosec x, right? And cosec x does not mean sine inverse x. Please get things clear in your mind. Don't write like this and never write like this. Okay. If you do the question, put the inverse sign after sine and before x. Don't write like this sine x and then inverse. It is not equal. These are not equal. Okay. Let's move on. Now I have a question. Inverse of t function or trigonometric function is a function or not? Think before you answer. Pause the video and think for the answer. Well, let me reveal the answer then. What? It is not a function. But we are saying it is a function. I hope your expressions are like this. The answer is correct. It is not a function. Inverse of the trigonometric function is not a function. And we would be looking at this by the basic definition that is required for a function, for a set relation to be a function. Okay. So we will see that. Okay. So let me just give you an example in order to look whether it is a function or not. Let me take y equals to sine of x equals to half. Okay. Then if I just have to find the value of x, then I can write x equal to sine inverse of half. I just told you. And what would be its value? What do you need to do? You need to see when the value of sine, at what angle the sine would have the value half. And you know it is 30 degrees, that is pi by 6, right? So x would be pi by 6. Okay. Now, another question. Is there any other value of x which satisfies sine of x equal to half? That means, can I have other than this pi by 6 value which satisfies this equation, sine of x equal to half? Now, you know this answer very well. Please just think before you answer. In case you don't know, let me reveal the answer. Well, yes, there are other values of x possible other than pi by 6 which can satisfy this equality. Yes. If I take 5 pi by 6, right, which lies in the second quadrant, so its sine is also equal to half. So that means I write directly over here x equal to pi by 6. You will write x equal to sine inverse of half, which is equal to pi by 6. So x can also be pi by 6. And x can also be 13 pi by 6, 17 pi by 6, minus 7 pi by 6, minus 11 pi by 6, and so on. And infinite number of values of x possible for this equation. Right? You have already known how to define these angles in your earlier classes. In the 11th class, you might have been taught about this. Okay, in case you don't know how to do this, I'll explain this a little bit later with with a clear example. Just take it for granted right now, and I'll understand you this thing a little bit later. Okay, so guys, I can have x as infinite number of values like both positive and negative, which satisfy this equation. Now, if I have to write in general that what would be the value of x, I can write like this. I can say that is sin x equal to a half, then x can be written as pi by 6 plus 2n pi and 5 pi by 6 plus 2n pi, where n is nothing but an integer. Okay. Also, this thing you would be knowing in earlier how to write in general value of x. In case you don't know, I'll tell you a little bit later. Okay. How you get these things. Just you need to generalize the thing, like you just put n equals to 0. So what you would be getting over here, if I just put n equals to 0, you would be getting pi by 6, which is the first angle that I get the value of x. If I put n equal to 0 over here, then I will be getting the second angle 5 pi by 6. If I just put n equal to 1, then what I will be getting pi by 6 plus 2 pi, which is nothing but the angle repeating itself. So there are two angles. Now, okay, let me just tell you something over here on sine of x equal to half. That means what? Sine is positive over here. Now, sine is positive, you know that. Sine is positive in the first quadrant and in the second quadrant. It is negative in the rest two quadrants, and it is having, okay. Now here it is positive, that means x would be either in first quadrant or in the second quadrant. It can never go in the third or fourth quadrant, right? Now I find the angles. One is pi by 6 and another is 5 pi by 6. Okay, and you know from 0 to 90, this is here angle 0 and here is angle here pi by 2. So from 0 to pi by 2 or in any quadrant, sine can take a particular value only once. Like sin x would be half in this quadrant only once at pi by 6, or any other value only once only, not twice. That means it can't have this half value at this and at two angles. It can't have in a single quadrant I'm talking about. Okay. So similarly, at pi by 6, it is assuming the value of after the 2 pi radians. That means after just moving ahead, at now this angle is 0. It can also be 2 pi. Then this angle would also be giving the value half. That would be pi by 6 plus 2n pi. Because this comes over here again after a period of 2n pi. I told you yesterday in the previous lecture that sine of x is a periodic function whose period is 2 pi. That means it repeats itself, it repeats its value after a period of 2 pi. Right. So similarly, I just write n. That n can be 1, 2, 3, 4 or infinite. It just repeats itself after 2n pi. Similarly, for this angle 5 pi by 6, after 2 pi it again comes like this and it will be 5 pi by 6 plus 2 pi. Then 5 pi by 6 plus 4 pi. Then again. So that's why I can write x in general like this and like this. Okay. Now, could you tell the elements of this set which I am drawing like this? The set x comma half such that half is equal to 7. Basically, I just write the pairs of satisfying this equation like in this set form, where x is the angle, these angles, and y is nothing but fixed half. That is this. Okay. Can you write the elements? It would be this, just this only. You have to write the value of x only. Just copy the value of x. So it would be either pi by 6 plus 2n pi comma half or 5 pi by 6 plus 2n pi comma half, where n is an integer. It would be just this. Simple elements. Okay. So now I define a relation. This is basically a relation set with an ordered pair. Now thing comes. If I have to find the inverse of this set, okay, for finding the inverse from the set directly, you just need to swap the values of x and y. Okay, so this x would come on the second component and half would come on the first. That means this would be the inverse of this set. If you given any set satisfying any condition and you have to find this inverse, just swap these values. That would be the inverse of that set. So that means its inverse, I consider the elements. So again swapping that values, that this value and half would be swapping half comma x would be swapping, and the inverse of this set would now be this. Clear? Now could you tell why the inverse of above function is not a function? It's easy. Okay, let me only tell you why it is not a function. Clear answer. We can directly see for function what you want. Two different ordered pairs must not have the same first component. Now, here I can consider the pair having this component, pi by 6 plus 2n pi and 5 pi by 6 plus 2n. Now, these are not always the same. Suppose I take n equal to 0, then it would be 5 pi by 6 and it would be 5 pi by 6. Right? That means this ordered pair and this ordered pair are both different for the values of n, for some values of n. Right? But they have this first component as the same. Ordered pairs are defined like this only. Just putting the value of n, you will get the different ordered pairs. But their first element is same, or the first component is same basically, which is, that means for two different pairs I get the same first component. So thus I can say that inverse of t function is not a function. It is not satisfying the property of a function, na? And this is nothing but the inverse only. What is x? Sine inverse half. The inverse function only. So that's why I can say that inverse of a t function is not a function. And this I just shown you with the help of an example. In general, we can also say if it is not satisfying the this thing for sine x, that is not satisfying for any trigonometric function. Okay, so that's why I can say that inverse of a trigonometric function is not a function. Okay, this is the now. Let's move ahead. So I have revealed the important thing to you that inverse over t function is not a function, and you might be having some of the questions in your mind. Then if it is not a function, why are we studying this? And how we write it is a function that inverse t function. Why are we using the word function over here if it is not a function? I'll answer all your questions after this questionnaire. Let's have some questions again to check how much you understand, how much you got the thing. Okay, so again we have the three questions. First one is asking you to find the value of sine inverse of 1 by root 2, giving you two options. Second one is asking you whether this set equals to this set, true or false. And the third one is asking you or saying you basically that y is equal to tan of x equal to 1, then what would be the value of x in general. Okay, I tell you the method earlier, how to find the value in general. Please pause the video right now, solve these questions, and then look at the answers. So I hope you solve these three questions and you are now ready to look at the answers. So let me reveal the answers then. These are the answers. For the first option, second option is correct. For the first question, second option is correct. It's pi by 4. For the second question, second option is correct. It's false. And for the third one, the first option is correct. That it would be pi by 4 plus n pi n is it. In case you get all these three answers correct, very good. You are all set with the inverse trigonometric functions. In case you didn't get all the answers correct or some are correct or no answer is correct, then please look at the explanation in order to understand the concept more clearly. Okay, let's now look at the explanation. For the first question, you need to find the value of sine inverse of 1 by root, right? What we know, you need to find the value of this sine inverse of 1 by root. Just don't look at the answer. I am telling you how to do it. The method that I told you. What you need to do if you have to find the sine inverse, you have to look this trigonometric function sine and what value you need to get. So when would I, at what angle alpha I would be having the value of sine is 1 by root 2. From the trigonometric tables, you know that sine of pi by 4, that means sine of 45 degrees is 1 by root 2. That's it. So pi by 4 would be sine inverse 1 by root 2, as we did earlier. So that means pi by 4 is the correct answer, so thus B is correct. Very easy question if you just do it properly. For the second question, okay, so you are given that this set, whether this set equals to this set. Okay, it was the question that this set equals to this set or not. Okay, so the bracket is missing over there. And it is not equal basically. Now, if you are confused, you would say, why? Why they are not equal? Just clearly look at the question. Every time I told you, just look at the question. First set is containing the pair x comma y is equal to sec inverse x. Okay. Second set containing the also the pair x comma y such that y is equal to asc sec x. Okay, I told you in another way to write the any inverse trigonometric function is using the word arc, arc, not the word asc. Correct? We do not use this word asc. We use the word arc in order to write this sec inverse x. So that's why these are not equal. This is nothing. This is nothing a set. There is no word like asc. Okay. So these are not equal basically. So thus it is false. B is false. It's correct. The B statement which says false is correct. Okay. So these two are the easy ones. Now the main is the third one question. Okay. So you are given y is equal to tan of x is equal to 1 and you need to find the generalized value of x. How to do this? Very easy. Firstly, again, first thing you need to do the trick. At what angle alpha the value of 10 is 1? You know that 10 of pi by 4 is 1. So pi by 4 would be tan inverse 1. So one value you get the value of x is 1, pi by 4. Now use this method which I told you about. Sine is positive in which quadrant? You have this thing. All sine, tan and cos. That means sine is positive in the first quadrant and in the third quadrant, and negative in the rest of the quadrants. So you get pi by 4 in the first quadrant. That is the only value satisfying this inequality. Tan of x is 1. So you must get the value in the third quadrant as well, which is nothing but pi by 4, if you know, because this is only the 45 degree in this 5 pi in this quadrant. If this is the 90 degree angle. Okay. Now again, as we did, again next value would be, this is pi by 4. What is 2 pi by 4? This is the trick which I used to do. So you find one angle is pi by 4. Okay. What is 2 pi by 4? This is pi by 2 is 2 pi by 4. What is 3 pi by 4? 45 degree angle in the second quadrant. What is 4 pi by 4? Which is pi. What is 5 pi by 4? The 45 degree angle in the third quadrant, which I write like this. What is 6 pi by 4? 270 degree. What is 7 pi by 4? The 45 degree angle in the fourth quadrant. But we don't need this. Then what is 8 pi by 4? It is 2 pi. Right? 8 pi by 4 is 2 pi. The next would be 9 pi by 4, which I write. Similarly, I just count and write the angles. And for the negative one also, I can write like this. Negative ones, I do not have to move anti-clockwise. I have to move this clockwise direction. So this for the negative ones, I have this as 0. One angle is pi by 4. Another I will get over here. So this will be 0. Now on moving down in clockwise direction, I would be having the negative angles. So what would be having? It would be pi by 4, 0. Then minus pi by 4, minus 2 pi by 4, and it would be minus 3 pi by 4. Which is this. Then minus 4 pi by 4 is this line, because this is minus 180. Okay. Then minus 5 pi by 4, minus 6 pi by 4, and this would be minus 7 pi by 4. And similarly, you go on and you write and so on. You just need not to calculate all the angles because these are infinite. So x would be tan inverse 1. Would be, these are all angles, right? 5 by 4, 5 pi by 4, 9 pi by 4, and so on. And in negative also. Minus 3 pi by 4, minus 7 pi by 4, minus 11 pi by 4, and so on. So in general, you can write over here 5 pi by 4 plus n pi only. Okay. So on putting the value of n, you will get all these angles over here. Now you don't need to classify them as two different now, like we did in sine. We just need one, and that's enough. Suppose I put n equal to 0, it would be 5 by 4. N equal to 1, it would be 5 pi by 4. N equal to 2, 9 pi by 4, and so on. If I put n as negative, like minus 1, so it would be minus 3 pi by 4, minus 2, minus 7 pi by 4, minus 3, minus 7 pi by 4, and so on. So I told you this method second time. I hope so now you are clear with this method. In case you are further not clear with this method, I will told you this method a little bit later, as I told you earlier, when we would be doing the examples. Okay. Let's now move further. Now the question you would be considering in your mind will be considered. That why inverse t functions are called as the inverse circular function. Why are these called circular? Why is there need to write them as circular functions? Okay, so it's very easy. It is just because of this fact that we can use the unit circle to write the t function or to define the trigonometric function. I use the word circular in place of t. Inverse is just the same. Inverse function can also be called as circular function because I can use a unit circle to define it. Unit circle is the circle basically of unit radius. Unit means 1. Unit radius means radius 1. A circle of radius 1 is a unit circle. Okay. So let me just draw a circle. Drawing the axis and 4 points. One is O, which is the center. B, one is C, and the one is B. And drawing an angle alpha, which meets at the circle at point A. Okay. Now, can you just tell what is this AB length? Basically, just use the Pythagoras theorem. This angle is 90 degree and this angle is alpha. So what would be this? What would be sine alpha? Sine alpha would be what? Perpendicular upon hypotenuse. Now what is hypotenuse? Can you guess? It's 1. I said now it's a unit circle. Means a circle of radius 1 and O is what? Radius only. So it would be 1. So sine theta, sine of alpha would be this perpendicular AB over AO. Now AO is 1. So AB would be sine of alpha. Similarly, what would be cos of alpha? Okay, I can write like this. This angle would be, this angle would also be alpha. And this is the 90. Clear? Cos of alpha is base upon hypotenuse. So this is the base AC and this is the hypotenuse. So that means hypotenuse is 1. That means AC would be cos of alpha. Okay. So with this unit circle, that means unit radius circle, okay, let me just define it. It is the radius 1. I define two trigonometric functions, one is sine alpha and another is cos alpha. And using Pythagoras theorem, I did this in the triangles AOB, which is this one, and in the triangle OAC. I get these things. And with the help of these things, I can obtain tan alpha, cot alpha, sec alpha, and cosec alpha as well. Okay. So that's why I call the trigonometric functions as the circular functions, because I can obtain them with the help of a unit circle. And thus, the inverse trigonometric functions are also called as inverse circular functions. This is just an extra knowledge for you. You must be knowing the concepts, right? And the names, what we call them. Someone asks you, define inverse circular functions. Then you would be like, what are these? I don't know. So you must know these things, right? I hope you are all clear. So let's now have inverses of trigonometric functions. Now the inverse of a trigonometric function is found by interchanging the x and y in the defining equation, as I told you. Suppose if you have to find the inverse of this set x comma y such that y is equal to sine of x, what you will be doing? There are two things to do. I told you earlier. First thing I told you earlier, just interchange this x and y. That means you write in place of x comma y, you write y comma x. Okay, and leave this equation as it is. This is the first thing you can do, and this is the second thing which you can do. Interchange x and y in the defining equation. This equation. Leave this pair as it is and just interchange x and y. So in place of y write x and in place of x write y like this. So it would be x would be sine of y. Either you do this or you do this. Please don't do both. That means you reverse this also and reverse this also. Don't do. Either just reverse this ordered pair or just interchange. Okay? Yes. So you can also write x comma y equal to sine inverse x comma y is equal to arc sin x. Just see whether it is written arc or something else. You can only write arc in place of sine inverse x, arc sin x, nothing else. Okay. So I hope you are all clear up till this now. So let's just end this session with again some homework questions. So let us now end this session with the homework questions. So here are the homework questions. In the first question, it is given y equals to cot of x equals to root 3. Then you need to find the value of x given the options. For the second, you have given a set and you need to find its inverse. Which of the following four options among them which is correct? Then again, in the third question, you have to find the value of a, where cosec of a is nothing but 2 by root 3 from the four options given to you. N is a integer. Then in the fourth question, you have to find the value of arc cot of infinity, and it is given to you that its value is 1. Then you need to check whether it's true or false. And in the last question also you need to verify whether sec inverse of minus root 2 is 5 pi by 4 minus n pi, where n is an integer, so it's true or false. So you need to just verify this. So these are the homework questions. Please practice these questions before coming to the next class. And I hope so you are clear with today's discussion of the inverse trigonometric functions. In case you are still not clear with anything, then please put down your query in the comments. So with this note, let me end this session. In case you find this video helpful, please like this video, share this video and subscribe my channel. Please do these things. Thank you.